All right, so a typical atom has a diameter of an angstrom, or 1.0 times 10 to the negative 10 meters. What is this in inches? Approximately how many atoms are in a 1 centimeter line, assuming that they touch? So this is really like a two-parter, right? There's part A. So let's do part A. What is this in inches? So this is just a straight up conversion. So we start with what's given to us. So we're going to say 1.0 times 10 to the negative 10, which is an angstrom. 10 to the negative 10 meters is an angstrom. I'll tell you that a lot. And then I need to know the association or the conversion factor from inches to meters. So I will tell you that over here on the side. There are 39.37 inches is equal to 1 meter. So now when you're doing conversions, I have two choices. I'm going to decide where I'm going to put the meters or I'm going to put the inches. I could use the inches or the meters. But what I'm going to do is I'm going to select meters on the bottom and put inches on the top, because what that allows me to do is as I crank through this bad boy, I'm going to cancel these out. Does that make sense? So that means on the top I have 39.37 inches are equal to 1 meter. So now when I multiply that out, I'm going to get it's equal to 39, because remember when you do this, you just multiply this number by this number and then tack on the powers of 10. Oops, I forgot to write out, that's 10 to the negative 10. So technically what I have here is I have 39.37 times 10 to the negative 10. Now that could be rewritten as 3.937 times 10 to the negative 9, right? Because this really isn't scientific notation until I have, remember this first term has to be between 0 and 10, right? So then now that I got that, actually 1 and 9 I think is what the textbook would say. Now it doesn't discuss uncertainty, so this kind of piggybacks on the last question. So I got to factor in the precision of the measurement. So in this particular case, I have two significant figures here. This is a conversion ratio, but the lowest measurement that I have is two significant figures. So I could make this two significant figures by saying 3.9 times 10 to the negative 9. Oh, we got to put the units on that. That's inches, right? That was the whole point, was to convert it to inches. So that's part A. Now for part B, it says how many atoms are there in a 1 centimeter line. Well, now I've just got to convert this. So I'm going to start with 1 centimeter. And then I'm going to add, because they're asking you how many atoms. So believe it or not, this is just a conversion. Okay? I'm going to go from centimeters to atoms. So the first thing I'm going to do is I've got to convert everything to meters, because meters are the standard. In other words, how many, so I'm going to convert centimeters to meters. What goes on the bottom? What units go on the bottom? Meters or centimeters? Okay, they said both. Why do you think meters? That's what we did for the last one. Why did you say centimeters?
Because I thought you want the one that you're trying to convert. You want the one that you're trying to convert to on the top.
Yeah, but we're not converting to meters. There's a better answer. We want centimeters on the bottom because what we're going to end up doing is we're going to cancel them. Okay? So we always want centimeters on the bottom because you're trying to cancel that with this. You got centimeters here, so you want centimeters here so you can cancel them. So there's 100 centimeters, and they're equal to 1 meter. Now we're going to convert this to atoms. What I kind of glossed over is that because we're converting it to atoms, it says that 1 atom is equal to this length. That's going to be important in a second. So now I can say if I have 1 atom, and that's equal to 1.0 times 10 to the negative 10 meters, I got to write a conversion factor. Do I put atoms or meters on the bottom? What do I have up here? Meters. So I got to put what here? Meters. And so that means the atoms go on the top. So how many meters? 1.0 times 10 to the negative 10 is equal to 1 atom. Now, I did that on purpose because meters divided by meters is 1, so they cancel out. So if I rewrite this after all the cancellations, I've got 1.0 times 1 times 1 times atoms. Then on the bottom here, I have 100 times 1.0 times 10 to the negative 10. Now I'm going to clean this up a little bit. I'm going to say 1.0 divided by 1.0 is 1.0. Now this is a tricky one. What's another way to say 100? Can I say 10 to the second power? Yeah. So on my very next line, I'm going to come down because I'm starting to run out of room. 1 times 1 is just 1. So I've got 1 atoms on the top. And on the bottom, what's 10 to the second power times 10 to the negative 10? What's the shortcut? What do we do with the powers? Yep, so it's 10 to the negative 8. Now, I don't like negative 8s. So what do? How do I toss this negative 8, this power of 10 to the negative 8, and make it positive? Flip it up. So I'm going to say 1. Now, I'm technically going to say 1.0. Right? Because we started off with 2 significant figures, so I can't just put 1. 1.0 times 10 to the positive 8, right? It becomes positive when I flip it up, atoms. And that, my friends, is the answer.